Use the rational root theorem to list all the possible rational roots for each equation. So that's all I want you to do. You don't have to find the actual roots. So remember, you have to get the factors of the constant. In this case, it's 15. So it's plus or minus 15, plus or minus 10. No, take that back. Plus or minus 5, plus or minus 3, plus or minus 1, and this is all divided by 1. Plus or minus 1. So if I had to make a list, it would be plus or minus 15, plus or minus 5, plus or minus 3, plus or minus 1. So that would be the list, the possible roots for number 1. Okay. I'm going to make this a little bit bigger. Okay. We're going to go ahead and list the possible roots for number 2. We're going to get the constant. In this case, it's 4. It's 4. And then you have to get the factors of the leading coefficient. So it's plus or minus 4, plus or minus 2, plus or minus 1. 36 is plus or minus 36, plus or minus 12. Plus or minus minus 9, plus or minus 4, plus or minus 3, plus or minus 2, plus or minus 1. So we have 36, 12, 9, 4, 3, 2, and 1. So we would have 9 over 36. So let me make the list. Plus or minus 9 over 36. Plus or minus 9 over 12. Plus or minus 9 over, in this case, 9. Plus or minus 9 over 4. Plus or minus 9 over 3. Plus or minus 9 over 2. Plus or minus 9. So in this one, we do have a lot of them. So I'm going to go ahead and do some of them on top. So we have plus or minus 2 over 36. Plus or minus 2 over 12. Plus or minus 2 over 9. Plus or minus 2 over 4. Plus or minus 2 over 3. Plus or minus 2 over 2. And then you have plus or minus 2. And then the last set we have is actually the 1 over 36. So we have plus or minus 1 over 36, plus or minus 1 over 12, plus or minus 1 over 9, plus or minus 1 over 4, plus or minus 1 over 3, plus or minus 1 over 2, plus or minus 1. Yeah, so there is a lot of possible roots for number 2. And I didn't simplify, so I don't expect you to simplify either. Okay. Let's go to number 3. Let's go to number 3. So what we're going to do is we're going to find the constants, we're going to find the factors of the constant. In this case, it's 1. And then find the factors of the leading coefficient. In this case, we have plus or minus 1. We have plus or minus 2, plus or minus 1. So what are the possible roots? Plus or minus 1 over 2, plus or minus 1. And that's a very short list in contrast to number 2. Okay. Okay, so let's go ahead and do number 4. Let's figure out the possible list for number 4, and I'm going to go ahead and use a different color. So we're going to get the factors of 4 over the factors of 12. So we have plus or minus 4, plus or minus 2, plus or minus 1, divided by plus or minus 12, plus or minus 4, plus or minus 6, plus or minus 2, plus or minus 1. So I'm going to go ahead and list them here, and I'll use a different color. We'll use this color. So we have plus or minus 4 over 12, plus or minus 4 over 4, plus or minus 4 over 6, plus or minus 4 over 2, plus or minus 4 over 1. I'm going to use a different color for 2. Plus or minus 2 over 12, plus or minus 2 over 4, plus or minus 2 over 6, plus or minus 2 over 2, plus or minus 2 over 1. And now I'm going to use a different color for 1. So we have plus or minus 1 over 12, plus or minus 1 over 4, plus or minus 1 over 6, plus or minus 1 over 2, plus or minus 1. So I think I've kind of drilled a point as to how to find the possible factors. Now you see the green ones, you see the blue ones, and you see the red ones. The red ones are already simplified. Now the blue and the yellow you'd have to, the blue and the green you'd have to simplify. We're going to go ahead and use our rational root theorem to figure out the possible roots. In this case, we have to make sure we get the possible factors of 8 compared to the possible factors of 1. And we know it could be positive 8 or negative 8 over positive negative 4, positive negative 2, positive negative 1. And since we're dividing by 1, it's going to be the same list. Positive negative 8, positive negative 4, positive negative 2, positive negative 1. So we're going to have to just guess and see what it could possibly be. I'm going to pick 2. I'm going to say that the solution is x equal 2. So you have 1, negative 5, 2, and 8. Remember that I'm going to be using synthetic division. Try to do this on your own if you can. 2 times 1 is 2. Negative 5 plus 2 gives you negative 3. 2 times negative 3 is negative 6. 2 plus negative 6 is negative 4. 2 times negative 4 is negative 8. 8 minus 8 is 0. And that is a root. Or we say that is a solution. So I'm going to put it up here just so I can put it on the side. X equals 2. And so now we have A is equal to 1, B is equal to negative 3, and C is equal to negative 4. So what do we have? We have x squared minus 3x minus 4 equals 0. So let's go ahead and use a quadratic formula. Remember that A is equal to 1, B is equal to negative 3, and C is equal to negative 4. So if we're going to use a quadratic formula, I'm going to go ahead and move this to the side just a little bit here. Oh, I can't. So I'm going to move it over here. So we have the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. So I have x equals negative b, in this case it's 3, plus or minus square root. Negative 3 squared is 9 minus 4 times 1 times negative 4, which is going to be good. You're going to see that right now. 2 times a is 2. So x equals 3 plus or minus square root. Negative 4 times negative 4 is 16 plus 9 is 25. And guess what? You can get the square root of 25. So you have x equals 3 plus the square root of 25, which is 5 over 2. So that's 4. The other possible answer is 3 minus 5 over 2. 3 minus 5 is negative 2 over 2 gives you negative 1. So what are the answers? X equal 2, x equal 4, x equal negative 1. For negative 6, we're going to figure out the possible rational roots. So we have 15 over 1. So we have plus or minus 15, plus or minus 5, plus or minus 3, plus or minus 1. This will be all over 1. So my possible answers are positive minus 15, plus or minus 15, plus or minus 5, plus or minus 3, plus or minus 1, and it's all divided by 1, so that's my list. I'm going to try 5. So I have 1, 1, negative 17, and then 15. So I have 1, 5 times 1 is 5, 5 plus 1 is 6. 5 times 6 is 30. Negative 17 plus 30 is 13. 5 times 13 is 65. And that's not going to work. Okay. Let's try 3. So let's try 3. So we have 1, 1, negative 17, 15, 1. 3 times 1 is 3. 1 plus 3 is 4. 3 times 4 is 12. Negative 17 plus 12 gives you 5. Negative 5. 3 times negative 5 gives you negative 15. 15 minus 15 is 0. That's your remainder. So guess what? Our first answer is x equals 3. So now let me write down the polynomial. We have x squared plus 4x minus 5 equals 0. We can solve this by factoring. We have x. So we have x minus 5. No, x plus 5, x minus 1. So x equals negative 5, and x equals 1. So our solution is x equals 3, x equals negative 5, x equals 1.